So we have derived the characteristic equation, and here is second degree polynomial. So we are having two roots which are not equal real. We have two roots which are equal, and we have two roots which are complex. So number one, we are having two roots of this equation m1 and m2. We say m1 is not equal to m2, and m1, m2 are real. So this is the case. Then we are having y is equal to mx. We get y is equal to x to the power m1, and y, this is my y1. y2 is x to the power m2. When I write the solution, my solution is y equal to c1 y1 plus c2 y2. So a very simple case. We have the solution. This is case 1. So we come to the case 2. Case 2 is, I'll get here the solutions m1, m2, m1 and m2, but we're having m1 is equal to m2, they are equal. When they are equal, now we want to discuss the solution. The solutions of this one will be equal to y1 is equal to x to the power m1, and y2 is equal to x to the power m1. Here we're having the root is repeated, then we use our formula, then y2 is equal to y1 integral minus integral p of x dx e to power, and then I'm having here y1 whole square into dx. When we solve this one with the help of this formula, then we are going to get it here. I'll get here this equal to y2 is equal to y1 ln of x. So here will be y2. So I will write my y2, now this is modified, we get here x to the power m1 ln of x. So whenever we having roots are repeating, multiply by ln of x. So having the second solution, y2 is x to the power m1 ln of x, I can write my general solution say c1 y1 plus c2 y2. If I take here x bigger than 0, then I can write y equal to c1 x to the power m1 plus c2 x to the power m1, and we get here ln of x. So we don't need to write the absolute value with that one, because we have already identified that this is the x is bigger than 0. This was case 2. Case 3 is we get the complex root in form of alpha plus minus iota beta. So is y is equal to x to the power m. When I simplify this one, my result will be y equal to x to the power alpha, and we get here c1 cosine beta ln of x plus c2 sine beta ln of x. So these are the cases that we are having here. The solution of the equation, we having this, as I having this equation was a2 y double dash plus a2x square y double dash plus a1x y dash plus a0 y equal to 0, and we taken here our x is bigger than 0. So our substitution was y is equal to x to the power m, and when we make the substitution, we get here our characteristic equation. This I give you the derivation of the characteristic equation. Then we have three cases. Case 1, we have two roots, but they are not equal but real. So we get two solutions y1, y2. We take the linear combination of the solution. We have in second case, there are two solutions m1, m2, but they are equal. So we use this formula to find the second solution, because they are equal solution. One solution is given. You can find this second solution. That is become here m1 ln of x. We remove this one because we have already taken mx is bigger than 0. So this is my y2. I can write the linear combination of this one as c1 x to the power m plus c2 x to the power m1 ln of x. So this is my second case. Case 3 is that we are having the complex roots. We substitute alpha plus minus iota beta and simplify this one. We get here y equal to x to the power alpha c1 cosine beta ln of x and c1 sine beta. Where we having x, so before in the last one, here we are having ln of x. That you remember, because you remember when root was repeating, we multiply by x, but here we multiply by ln of x. So practically I will tell you how we are replacing this x by ln of x in this case, because the substitution is y is equal to x to the power m. I will explain you this with the help of example. For learning more, we take a quick review that we have different type of roots, and then how we can write the solution. In this case, we have the differential equation. As you know, we are having here the second order differential equation a 2x y double dash plus a 1 x y dash x square y double dash plus a 0 y equal to 0. And find the roots m1, m2. Their two roots are m1 and m2. For example, my m1, m2 is number one case. m1 is equal to -1, and m2 is equal to 4. So I want to write my general solution. My general solution will be y equal to c1 x to the power m1 plus c2 x to the power m2. So this is my general solution. Now if I'm having the case that we are having the equation m1 is equal to 1 and m2 is equal to 1, roots are repeating, then we are having y1 is equal to c1x plus c2x, and then we multiply by the factor because root is repeating, and then factor is ln of x. So this we multiply, and here we can take as a note. So if I am having here the roots as m1 is equal to m2 is equal to m3 and is equal to 2. So what's my y? My y will be equal to c1 x square plus c2 x square ln of x plus, now we are having here the third one, c3 x square, and here multiply by x square, multiply by ln of x once again. So we are having here ln of x whole square. Number 3, I'm having the roots, complex roots. I'm having here m1 and m2. This is 4 plus minus 5i, alpha plus minus iota beta. So I have here y is equal to x to the power alpha, c1 cosine beta, beta is 5, ln of x, plus c2 sine beta, beta is 5, ln of x. So this is my solution in case we are having the complex roots. Number 4, we take the case when I am having here the mixed solutions. My m1 is equal to 1, m2 is equal to 2, and I have the complex root m3 and m4. They are plus minus iota. Here alpha is 0. Now let's see what's the solution of this one. We're having y is equal to c1 x to the power m plus c2 x to the power m2, that's x to the power 2, plus alpha is 0. So alpha is 0, x to the power 0 is 1. Get c1, beta is 1. Here's c3. We're having here cosine beta is 1. We get here ln of x. Plus c4 sine beta is 1. We get here ln of x. So this is my solution in case we have the complex roots. Number 5, we have the roots which are complex and they are repeating. We have plus minus I and plus minus I. They are repeating roots. So what we do, we get here y is equal to c1 cosine ln of x, beta is 1, alpha is 0, plus c2 sine ln of x, beta is 1, alpha is 0, plus, now their roots are repeating, I put them in the bracket. I have c3 cosine ln of x plus c4 sine ln of x, this is my angle, and here I multiply this one because roots are repeating, I multiply this one by ln of x. So here this factor is coming because the roots are repeating, we multiply by ln of x. This is the idea, you know, we have been doing these problems, so I know that you know this idea and you can easily copy that one. Once we get the roots, we can write the general solution. Now I give you the example to for this one. So here I take you the example, give you the example, solve the Cauchy Euler equation, and here we are having here x square y double dash plus xy dash, this is Cauchy Euler equation. Solution of this one, we substitute y is equal to x to the power m, then y dash is equal to m x to the power m minus 1, y double dash is equal to m into m minus 1 x to the power m minus 2. I multiply here by x. I get here x y dash is equal to x m x to the power m minus 1 into x, and that will give me m x to the power m. Then I have x square y double dash x square y double dash is equal to m minus 1 x square m minus 2 into x square. So x square is cancelled. We get here m minus 1 x to the power m. We substitute in our differential equation. We'll get here the x square y double dash is m minus 1 x to the power m. Then xy dash is plus m x to the power m, and y is x to the power m is equal to 0. We take x to the power m common. We get here m square minus m plus m minus 1 is equal to 0. As before, I told you x to the power m is not equal to 0. When x to the power m is not equal to 0, then we can see that we are having here the equation in the form that we will get here x to the power m is not equal to 0. We get here m square minus 1 is equal to 0. This is our characteristic equation. And here we find roots of this characteristic equation, and we can write our general solution. The roots of this one is m minus 1 into m plus 1 equal to 0. The roots will be m is equal to minus 1 and m is equal to 1. So I can write my y, the roots are not equal, c1 x to the power minus 1 plus c2 x, that's my general solution. So this is how we can find the solution. We are having two roots which are not equal, different, so we can write c1 x to the power m plus c2. But here the main thing is that we make the substitution. So I just give you the formula that how we can do it. For example, I have here a m square y double dash plus b a x square y double dash plus b x y dash plus cy equal to 0. My characteristic equation will be m square plus b minus a m plus c equal to 0 always. When I substitute the value y equal to x to the power m. We can check this one. I'm having here m square here. In this case, when you take, then my a is equal to 1, my b is equal to 1, my c is equal to minus 1. So we're having b minus a, that's equal to 0. So m square minus 0, and then c is equal to minus 1. I get here m square minus 1. So inshallah we apply this one to solve next problem.